All right. Okay, so in this video, what I wanted to go over was the procedure that you would follow if you wanted to be able to write a force vector that you knew lie along a particular line, a line that goes between two coordinates. This ends up using a couple different sort of strategies that you have to know how to do, and so I wanted to do an example for it. First of all, I wanted to outline what are the steps to writing this force vector. So there's basically three different things that you have to do in order to get to the vector itself. The first thing is you need to write a position vector that goes along the line. And of course, it's important that that position vector goes in the right direction. So if the force is pointing from A to B, you want a position vector that points from A to B. It's easy to figure out if you're doing it backwards or not, because you can look at the picture and sort of from the visual picture determine if, say the X, Y, and Z coordinates, should they be positive or negative? And as long as your value that you end up with gives those correct sort of positive or negative signs, then you know that you've done it correctly. And that's just if you're getting confused. Once you have that position vector, you want to turn it into a unit vector, because basically the unit vector has a magnitude of 1 but points in the correct direction. And so we have to know how to do that. Finally, in order to find the force vector itself, you multiply the unit vector by the magnitude of the force. That will give you a 3-component force with the correct X, Y, and Z components. So, making a position vector, turning it into a unit vector, then multiplying that unit vector by the magnitude of the force. That will give you a force, the force vector. So I thought it would be helpful if we had a particular example. And so this is actually problem 292 from your book. And so you could reference that if you wanted to. And so what I want to do is we're going to figure out how to write the force vector AB. Okay? And I think what's most helpful to get started, or I guess actually I should say, it's going to be the magnitude of AB times the unit vector that goes from A to B. Now, I find the best place to start in order to write a position vector, because that's our first step, is I always like to label the X, Y, and Z coordinates of the points that I'm going to be working with. I'm going to be wanting to write position vector AB, which is going to go from point A to point B. And so first of all, I want to look at this picture and I want to figure out what are the coordinates of A and B. And so the coordinates of A, when I'm looking at this picture, I can see that A is the tip of this pole, this vertical pole, that actually is lying along the y-axis and then has its height is represented in the z direction. Because it's along the y-axis, the x-coordinate is 0. Notice that it is 0.75 meters from the vertical z-axis, but in the direction of the negative y, because positive y is over here. So the y direction is minus 0.75. And finally, it's at the tip of the vertical pole, which we see right here, is labeled as being 3 meters high, and so its z-coordinate is 3. All right? Now, so those are going to be useful for me to use. This is really be AX, AY, and AZ. Those coordinates, really. Now, the other one we want to figure out is B, point B. Now, B is actually going to be given to us in a little bit of a different way. Notice that there's a line that goes from the origin to point B that's lying in the XY plane. So it's saying that the distance from the origin to point B is 2 meters. And then that 2-meter line is at an angle of 40 degrees with respect to the x-axis. And so that actually means that for the x-coordinate of point B is going to be 2 times the cosine of 40. The y-coordinate is going to be 2 times the sine of 40. And it's on the xy plane, so the z-coordinate is 0, just for reference sake, because we're going to be using the numbers. This is 1.53, this is 1.29, and this is 0. So these are bx, by, and bz. All right. Maybe you're smart enough to not have to do that step, but I just find it's really nice to sort of have those written down for me, so I always make sure that I'm doing the right thing. Now, remember that when we write a position vector, we always start at it's pointing to this one points to B, so we always do the B coordinates minus the A coordinates for this particular, the way that we want to write this position vector. So the x component is going to be bx minus ax. The y component is going to be by minus ay. And the z component is going to be bz minus az. And now we have those coordinates, and it's so easy, we really are just plugging and chugging. So we've got 1.53 minus 0 for the x coordinate. We got 1.29 minus a minus 0.75 for the y component. And for the z component, we have 0 minus 3. So our position vector that goes from A to B is 1.53 I plus 2.04 j minus 3k. Okay, and what I had said at the beginning, we can just pause for a moment and check and see if this makes sense. If I think about that vector that goes from A to B, if I think about how it's going to be pointing, I definitely think it has a positive x component, it has a negative z component, it has a positive y component. All this really tracks with my results, so I know that I did it right, unless I made a math mistake. Now, in order to change this into a unit vector, we take any vector and turn it into a unit vector, we divide the vector by its own magnitude. RAB, the magnitude, we take by taking the square of each component, squaring them and adding them together, taking the square root, and I got 3.94. And so the unit vector UAB is going to be found by taking this vector right here, dividing each term by the 3.94. Okay, just so you can see everything, if I do the division, I get 0.388 I plus 0.518 j minus 0.6761 k. That is my unit vector. Now, to find the vector that goes from A to B, I would multiply this unit vector times the magnitude. The magnitude of this vector, as it's shown on this picture, is 250 newtons times UAB, that unit vector. And so if I take this unit vector and multiply each term by 250, I will get the individual components of my vector. It's going to be 97I plus 129.5j minus 197.8k. And that's my force vector. I've done it. If you want to check your work, of course, you could use the Pythagorean theorem and see if this magnitude is 250. If it isn't, you made a little bit of a math mistake and you can go back and check it. So there are a lot of ways to check your work along the way. The other thing you could do is check that the magnitude of my unit vector is 1. And so lots of places, lots of opportunities to make mistakes and also to check your work. But hopefully this kind of helps you see what the steps are to make, to write a force vector. These are all tools that you're going to use frequently in this class, and so they'll become routine. But as we first learn, it might not be as familiar to us, so it might be a little bit harder. But hopefully you'll see that it's not so much that it's hard, but you just have to be really careful that you don't make a mistake along the way. It's a little bit tedious. So that's it for now.